In the last part of our lesson today, we're going to be simplifying square roots. And to simplify means to find another expression with the same value. It does not mean to find a decimal approximation. And in order to simplify square roots, we need to know our perfect squares. And so I've listed right here the first 12 perfect squares for you. In order to simplify a radical, you need to find the largest perfect square which will divide evenly into the number under your radical sign. For example, this is radical 48. I find the biggest square root that can divide evenly into it, which is 16. And so then I'm going to write the number appearing under your radical as the product of your perfect square and your answer. 48 is the same as 16 times 3. Okay, so then I give each number in the product its own radical sign. Okay, this is a rule of multiplying radicals. Radical 16 times 3 is the same as radical 16 times radical 3. And then all I have to do is simplify the perfect square. The square root of 16 is 4. So the square root of 48 simplifies all the way down to 4 radical 3. We're going to practice simplifying radicals now. Our first is radical 28. The biggest perfect square that can go into 28 evenly is 4. So I'm going to write this as the square root of 4 times 7 is 28. Now write each with their own radical sign, radical 4 times radical 7, and simplify. Square root of 4 is 2, and we have 2 radical 7 as our answer. Okay, we're going to skip the second one because that's the one that we already talked about up above, and we're going to look at the third one. Notice there's a number outside already. We've got 4 times radical 12. We'll deal with the 4 later on. The biggest perfect square that can go evenly into 12 is 4. 4 times 3 is 12. So I'm going to have 4 radical 4 times 3. Okay, and now I'm going to give each of these their own radical symbol. This is 4 times radical 4 times radical 3. And now when I simplify this radical, I get 2. All right, so this is 4 times 2 times radical 3. And then 4 times 2 is just 8. This is 8 radical 3. In example 4, again, I've got my number out front. I'll worry about that later. With 72, the biggest perfect square that goes evenly into 72 is 36. 36 times 2. So this is negative 2 times radical 36 times 2. Give each their own radical symbol now. Negative 2 times radical 36 times radical 2. I can simplify radical 36 to 6, negative 2 times 6 times radical 2, and then this just becomes negative 12 radical 2. In question number 7, notice that it's a radical of a fraction, 14 over 36. I can rewrite this as radical 14 over radical 36. Okay, and now I can't do anything with radical 14. There's no perfect square that goes nicely into 14, but I can simplify the denominator, radical 36, which equals 6. And so this in simplest form is just radical 14 over 6. Okay, similarly in question 8, I can rewrite this as radical 20 over radical 81. All right, well, radical 20, there is a perfect square, 4, that goes into it evenly. So this is radical 4 times 5 over radical 81, which is just 9. Okay, so now I can write this as radical 4 times radical 5 over 9. And then when I write this in simplest form, radical 4 is 2. So this is just going to be 2 radical 5 over 9. In example 9, notice we've got some variables under the radical symbol right now. I'm going to break this up into 3 separate radicals. I'm going to write this as radical 64 times radical m to the 6th times radical n to the 12th. Okay, and now I'm going to try to simplify each part of the radical. So I'm going to look at this. I know that radical 64 is equal to 8. All right. Times, all right, now I've got to think about how I can write this, the square root of m to the 6th. Well, the square root of m to the 6th is actually m to the 3rd power. If you remember working with your exponent rules, m to the 3rd times m to the 3rd, I add these together to give me m to the 6th power. And so now if I take the square root of m to the 6th, that gets me back to m to the 3rd power. And then very similarly to that, the square root of n to the 12th power is going to be n to the 6th power. N to the 6th times n to the 6th equals n to the 12th. And so this answer is all just 8m cubed n to the 6th power. In example 10, there aren't any radicals here, but it's important to remember how to simplify something that looks like this. We have 2 plus 4x divided by 2. I'm just going to write this as two different division problems. This whole thing is getting divided by 2. So I can break this up as 2 over 2 and then plus 4x over 2. And now when I simplify each part, 2 divided by 2 is 1, plus 4x divided by 2 is 2x. So this up here is just the same as writing 1 plus 2x. Question 11, again, I'm just going to write this as two different divisions. I'm going to have 3 over 6 plus 15w over 6. And now I can simplify each part. 3 divided by 6 is a half, plus 6 and 15 have a common factor of 3, so I can divide each part here by 3. All right, when I divide 15 by 3, it leaves me with 5, and don't forget the w, over 6 divided by 3, which is 2. Okay, so I can write it as 1/2 plus 5w over 2, or since the denominators are the same, I can rewrite it as just one fraction, 1 plus 5w over 2. Either one is acceptable. With the last one, we've got a return of the radical symbol here, and again, I'm just going to break this into two different divisions. 2 over 6 plus or minus, we pay attention to that sign there, radical 20 over 6. Okay, I can simplify the first part here. 2/6 is the same as a third, plus or minus. Radical 20, well, we did that one earlier, if I remember back up here. Radical 20, well, that was the same as radical 4 times 5, which simplified all the way down to 2 radical 5. And so I can rewrite this radical 20 as 2 radical 5 over 6. And now I can see again I have a 2 and a 6 that I can simplify, so I can write this as 1/3 plus or minus 1 radical 5 over 3. And now that the denominators are the same again, I can just write this as one fraction, 1 plus or minus 1 radical 5 is just radical 5, all over 3.